Okay, before we want something else, okay? I just quickly make sure you understand. When you say DLAB, okay, only one thing, make sure you understand for HIC in DLAB, how they working, okay?
Mhm.
You get any question on it? I just want to know, make sure you know HIC, like U6 or U7 or U5, U8.
Mr. Pham, I have a question about UC clock.
About what?
UC clock. Could you explain again how clock control UC? U6, please.
U6 will be a 374 IC. That means
Yes.
the clock, the electrical flip-flop. That means if you want the input at the 1D, 2D, 3D, go into the output of the 1Q, 2Q, 3Q, the requirement. First thing,
Hey, Mr. Pham, can I just jump in real quick?
yeah,
Before you, so, because this might help things out, explain the difference first before you, I want you to answer his question, but before you do that, explain the difference between U5 and U6, because basically they're kind of the same, aren't they?
they the same, but one will be the large U5, and another one U6 will be a electrical.
Okay.
That's the big difference.
And they're flip-flops, right?
That's just a flip-flop. U5,
U5 is the latch, and the U6 you said.
electrical.
Edge
Okay.
trigger.
Okay.
And they both flip-flops.
Yeah.
Okay, so if you want the data from input 1D, 2D, go inside U6, then you need the positive clock, okay,
Okay.
on pin number 12.
So this is the first requirement,
First
right?
requirement for the input here go to inside, but not
Okay.
outside yet. If you want the input, they already inside here, go to the output here, then pin number 1 must be low. Output control. They allow whatever inside.
Okay, and that is the second requirement.
Yeah. And you can say you find the same thing. If you want the input D0 to D7, go inside. You find then you need the LE must be at the logic 1.
Okay. Okay.
Not the clock, logic 1. And U5 they already connect pin 1 output enable to the route. Only telling you whatever coming in, they will be coming out.
Got it.
That's different from U6. U6 they can be coming in, but they're not coming out until pin 1 at the logic 0.
Yeah.
And then once again, Mr. Pham, like you said yesterday, on U6, pin 1 is and pin 1 on U5, they're like output enable, correct?
Right, the same way, the same thing. Only different company, they're using a different name.
Right. And then U5 uses the latch to move the data through, and U6 uses the clock to move the data through.
Right.
But in this case, on U5, since pin 1 is grounded, the information, once it goes in, it'll just keep moving.
Exactly.
And whereas on U6, the information can go in, but until the clock go, then and you get a active low on 1, then the information can go through.
Right.
All right, thank you.
Okay, anything else on the schematic? Okay, now I just go over the way the test supposed to be. So the first 1, 2 test, they send data go to U1 and they drop it back into the U2 for data 55AA. Okay, if that part, then now they will be send the data from U1, U3 and go into the U6, and the output U6 wrap it into input U7, and they go back to U2 and verify with the same data 55AA. So if that 1, that 2 part, that means you don't worry about U1, U3, and U2. If that 3 and 4 part, that means do not worry about U6 and U7. Okay? Then the last one, test the memory U number 8. So when you want to test U number 8, okay, for the data 55, okay, and the data AA, then first thing you must be apply address. And then you have to be apply data. Then you set the PB pin 5 to be 0 to write. Then you apply the negative positive pin number 18. So the data from U number 8 here will be go into the location you want in here. Okay.
Mr. Pham, that's what I was going to say to help people out, like on U8, where they see the letter A, like A0, 1, 2, 3, 4, so forth, that's the address side. And where they see D0, 1, 2, 3, so forth, that's the data side.
Right. This is the address right here.
Right. And the other side is the data.
Data.
And then those where you got pins 9 through 17, that's where information can come in or it can go out.
That address, okay?
No. I'm saying on that on the out on the D side.
Right. Okay, so now I will be going to you for the block diagram. Okay, now that's the one you're talking about, the block diagram. I'm telling you on the test 1 and 2. You see that? Data sent to U1, 8 here mean 8 bit. They go to U3 and they drop it into U2. Okay? And they verify. So related into this test, the P-corp probably cause of the failure can be U1, can be U2, can be U3, and also can be U4. That is a block diagram telling you how the signal goes. So that's why when you run the test, they fail test number 1, then you don't care about something else. Only what happened is something in here in order for troubleshooting. You're not troubleshooting in the memory. I think on this two test, we do nothing with the memory. Then now you can say on the second test, test 3 and 4. Okay, they're telling you the signal will be go to U1, U3, then they will be go to U6. They wrap it into U7. Okay, and they verify. So relate it into the to test. Some wrong. They can be U6, can be U7. Also, they have to be U4. I think U4 go to U10, okay? And also U9. So if you run the test, fail test 3 or 4, so you want to troubleshoot it, you need to concentrate on U6, U7, U4, U9, and U10.
Mr. Fan, U2 always is going to be used to verify the data?
Yeah, all the time.
Okay.
That means they they wrap it, okay, and they using the bus right here. 8-bit sharing, too many IC. However, that will be helping you when you get working on your hardware. You build the circuitry, you run the test. If they fail test number 3, that only make sure some wrong can be U6, U7, U4, U10, or U9. Nothing to do with U1, U2, or U3, or memory. Okay?
Hey, Mr. Pham, on that block diagram, you didn't give that to us.
No, I already carried to upload it.
Oh, what, you uploaded it?
Yeah,
Okay,
I given to you guys upload every time before we meet it.
okay, well, all right.
You have to say diagram for the test block.
Okay, thank you.
Make sure every time you get a meeting, you have to say what you need to upload.
Yeah, you're right. I'll find it.
Okay. And the last part here, that's the memory. So on the test the memory here, you need to apply address here. You need to apply the data usage here. Okay. And you write data to memory. Later on, you can read data from memory.
So, Mr. Pham,
Yeah.
when you write the address and the data, they all go through port A01, correct? Everything go through there.
You're talking about right
When you want to write something, so
to the memory.
the first thing you have to do is the address.
Right. You must be apply address.
So where do you input the address? Is it through PA01, port A1?
What he's saying, Mr. Pham, like when you want to apply the address, do you start at PA1? And I believe you do, because it goes in serial, come out parallel, and go from U1
Yeah.
to U3 to U5 to U8.
For sure, you still have to go from here.
Okay. Then after that, then you send the second batch of data through port A again, and that's the data that has to be written, right?
Exactly. Data still have to go the same way. However, now they go to U6.
Okay.
The thing is they sharing. Okay, 8-bit here. They sharing.
Okay. So both times you use the serialized data to bit 1, and then of course the data, the address or the data,
Right.
and then after that you either enable U3 and then write to port D or no, do the other thing.
Okay. So now that will be included into the function.
Mm-hmm.
One function I call a write address, right?
Right.
Write another function I call a write data.
Right address, right data. Yes.
Okay. So when you're using that function, they take care of everything. Data from here go. Okay.
Mm-hmm.
Okay. And when you write data, data go this way. Go
Oh.
to here.
Okay.
Okay.
Yep.
Otherwise, you know, if you have to listing every write statement, okay, write port A or whatever, that will be a lot confusing. Okay. Now I will be go into the program, okay, and try to help you out.
Hey, Mr. Pham, the colors that you are using on your scheme has any meaning? For instance, you have U1, U3, U2 with yellow. That there is a specific meaning for that color for those three
Okay,
components?
that will be telling you when you test for the 5 and 6, that 5 and 6, some wrong, they not U1, U3, U2.
Okay.
The thing is they already been tested. Okay? That means if you fail test number 5 and number 6, then something wrong. Maybe U5. Okay?
Okay, but not with the components of the other colors.
Yeah.
Got it. Thank you.
The thing is I'm using the test block diagram to telling you which IC we already been testing. So if you fail on the memory, what you need to do, make sure you get the right address. Make sure you get the right data. Okay? And something else still with U8 or write, read or whatever, enable. Okay? For troubleshooting. The thing is when you build, I'm not sure you can get a very good build. They can pass everything. So that's why when they fail, you know what's supposed to do. If I fail on test number 5, then my job, I can check, make sure I get the right address here. I get the right data here. Okay? So if it fail, can be U number 8 or U number 5 or U number 6. That means you concentrate on troubleshooting on this guy. And U7 when data coming out. You don't care about U1, U3, U2. But
Okay.
you really care about U4, U10, and U9. What else we need to know? Same thing when you're working. When they fail, then you need to really understand the path of the signal, where they go. They go to U1, then they go to U2, then they go to U5. And also the data, they will be go to U6, then later they will be go out to U7. If you really understand that not only technician that are engineering. Sometimes you run the test file, it fail. If you know how to do what to do, and I think you don't have enough time to troubleshoot it, except you don't know what to do. Try to rebuild it. No, we don't want to rebuild. Build one time. When it fails, try to figure out what's wrong, where missing the wire, or some worst case, IC itself they not working. So that's why I can tell you, I can be working in my company for 27 years. All the time I have to deal with this kind of problem. That means we're testing the circuit board, and now they fail. That's why I have to know how to fix it. I'm not expect your guy can get through, this thing. However, when you do in your lab in the class, you get it failed. You can get into the Zoom with me. I can help you to troubleshoot it. That's what you learn from. Next time you can get better. Okay, any question on this? If it's not, then I stop share on my iPad. I go back to my desktop to telling you on the program. Just a minute.
Hey, Mr. Pham, is that the new classroom we're going to be in when we come back?
On the June 14.
Where you're at?
What?
That room where you're at, is that the new classroom?
Now we return, I believe, will be on the 4th, September.
Yeah, but I know, is that the new classroom?
Same thing.
Oh, really?
Yeah, but two class will be two lab. 250 and 240. Okay? Will be two class, and every time you can see one instructor in the room 240 and another one 250, and also Sam will be in either room. So at that time, no more instruction lab, anything, only the lecture.
Okay.
The lecture, I still be online. The thing is, they not allow you to get 60, 70 students in one room, at least at this time. So you can get a 1 day for the lecture and about, 4 days for the lab. Okay, so now I want to share on my. Okay, now see how they're working. Okay, test number 1. Okay, you want expect data 55 and the math data here PCOP, then the first thing you call a serial data. You send the data file, and you must be enable U3. Then now you verify output. Okay, you can using that validate, or you using the same like I do. That means you can copy exactly this one. This is my software. You cannot change it. So that will be done with the test number 1. Okay, any question, you need to stop me, okay? And when test number 2, you understand we test the same U1, U2, U3. However, data now will be AA. So I say I want expect data will be AA. A PCOP a little different from the first one. On the PCOP here we have a no U4. If you following the instruction in the Excel, they will be the same. Then you can say send serial data here. Enable U3. And now you verify the output. Okay? Verify the output, measure data, pass or fail. Test number 3. Okay? So basically this coming out from your Excel. I want to test U4, U6, 7, U9, U10 for data file. What we need to do? First thing you say expect data file. PCOP will be include U4, 6, 7, 8, 9, and 10. Then you call the function you need to write serial data is file. And you need to enable U3. And now you want the data to go to U6, you need to apply U6 block function. Okay? And then after data already loaded into U6, you need go to the output, you need to call a function U6 output enable. Okay? Then you need to write the port B0821. That means you try to enable both U6 and U7. Okay? That means the way we design. So you can dropping data from output U6 to the input U7. Then you can measure. That one, maybe the people can follow up to like 120, but you don't know about like 125. So that make sure you make a note on that, on this test. You must write to port B 0821.
Sorry, test number 3, we should write to port B 0x21, right?
That's on test number 3, right?
Yeah.
Okay. That means first thing you have to send serial, right?
Yes.
You must be enable E3 to let go pass through U3. Then you need to apply the U6 block.
Yeah.
So they can loading inside the U6. Now you want it to be outside U6, then you have to call the function U6 output enable. And they already in the output of U6, then you must be using that one here.
Okay. Okay.
To wrap it into U7. Then you verify. That's it.
Okay.
Then when you go to test number 4, okay, they say test U6, U7. The thing is, the other thing they already working. Now they are just send data 55 to AA. So that's why pick up only U6, U7. You do the same thing. Okay? Drive serial AA. Enable U3. U6 lock. Then U6 output enable. And write to port B21. Same thing on the other one. And you verify data. Okay, now you will be tested memory data 55 at the address AA. That means you write the data 55 to address AA. Okay? So you expect data they supposed to be 55. And the peak of U5, U8, U10. So basically, that will be inside the Excel. Now we see. First thing, you call the function write address AA. Then you call the function write data 55. And you call the function write memory. So that means up to line 155, data already write into the location AA with the data 55. Now the second part on the test number 5, they asking you to write data AA but to location 55. They're not reading yet. Then you will be apply the same thing like the other one. First thing you need to call write address 55. Write data AA. Call the write memory. So now up to this point, you already write twice. First thing you write data 55 to location AA. The second thing you write the data AA to location 55. Then now you start reading. Reading address AA and the data should be 55. So in order to read it, you need to write address AA. Then you call the function read memory. Then you verify the data. Okay? And if you want to read the next address, that's number 6. Okay? Now they want to make sure you read address 55, you're able to get data AA. Expect data AA. Okay? And pre-copy file 8, same thing. You want to read, you need to write address. Then you call the function read memory. Okay? So that will be done. Okay? And this is the function to test the ADC data. I already given to you in the Excel. Everything regarding into this test, you just copy. Okay? Now I want to tell you few things. Maybe you want to know. Okay, now talking about function definition. That one you already get before. Serial, okay? Enable U3, U5 large. That in Excel, in void U6 clock. Okay, void U6 output enable. Okay, I want to talking here. I'm talking about memory. Now, you get a function. Write address to memory integer add. Why they need a parameter here? The reason is when you call this function, you have to know what address you want. Then you can put in here. Okay? Inside that one, you say write to port D, memory enable 1, enable U3, and you call a serial data with ADD. If you say call this write address 0x55, so they will be send you 55. And you enable U3 and U5 large. Then the data will be ready at address. Okay? And now you want to write the data to the memory. Same thing. Integer data, DAT. Depending on what data you want to write. Is it 0x55, 0xAA, or any data? So in that function, you need to call that function here. DAT means whatever you call. 55, they go 55. AA, they go AA. FF, they go FF. Then you need to enable U3. Then you have to apply U6 clock. That means they will be clocked into the U6. Then now you need to call function U6 output enable. So they will be ready at the memory data. When you call a function write to memory. So what you need to do, okay, you need to write to port D. Make sure you set the memory enable to 1. And you write to port B, okay, enable output U6. You need to write to port D. Put the memory enable to 0. Then they write port D. Bring memory enable to 1.
Those are the parameters for U8 in your function, right, Mr. Pham?
That for U8.
Okay, thank you.
The thing is when you want to apply data to the memory, you need to write a thread first. You need to write a data. Then you have to call this function. They will be help you to put the data into that address location. And this one will be, I believe, in Excel. You already see everything here. Okay?
Mr. Pham, can you go back up just a little bit to the, let's see, one more. Okay, write to this one, write address to memory.
Okay.
You first write to port D and then enable U3. And then you write to serialize data and then you enable U3 again. Why do we have to do U3 again?
The thing is, if you not enable U3, data cannot go into U5. I show you.
But then you already set it to low, active low.
Now, okay, I show you. Okay, you want to write the address.
Mm-hmm.
That means data have to go this way.
Right.
So if you not enable U3, data cannot go to here.
Right.
Then you can lastly, then data can go here.
Right.
That's why you need enable U3.
So but then you enable U3 first, then you digitize the number to U1. Whoops.
Just a minute. Okay, now you see that? Enable E3, then you get the that means I get a double, right?
Right. That's why I don't understand why you need it twice.
Yeah. Thank you.
Oh, okay. All right.
Okay. Write to memory. Now read memory. So you need to write to port B32. I want memory write at the logic 1. And U7 will be output enabled. And you write to port D. That means set memory enable equal to 0. Okay. That's it. Now, what I want for most of the students can do, okay? You can go to upload, okay, my program. Let's see, that program here, okay? You can control A, copy everything, and will be passed into your program, okay? So the first thing you can see in here, they get how many functions, okay? Then you need to create in your program for the function definition, okay? That means after the end man here, this is the function definition area, okay? Then you can copy everything and make the function definition. But you don't have to write anything in there, okay? I've given you example. I can insert the line here. Okay, let's see. Okay, so the first one, the one you already getting, okay, now, if you look in here, you get a void enable. Okay, I don't care about the first one. This one we already have it somewhere. And copy that one. Okay, copy that one. And you go into the function area. Definition. Okay. Right here. Okay. Then you can press them out. Okay, void everything here. Let's say no semicolon. Okay. Then you open the brace. Okay, whatever inside, I don't care for now. You close the brace. And you can say right here. And up enable U3. Enable U3. Okay, that's a function. Then you can go next one. Okay, then you can do
Different types of brackets there.
second one. Have to do all of them first. Okay, and now you copy this guy and do the same way. Okay, after you done for function definition. Then now you can compile to make sure, you know, you get no error. And if you want to fill out the what inside the function enable U3, you're looking into your Excel right here, right? Enable U3 right here. Only thing what they need, you need to try to port B 0, 0. That's it, they can done. And the next one, do it the same thing. Try to port B 0, 1. Take care of that. Everything I already given to you here. If you get a function definition, copy that one into your software. Okay, any question? Try to do the DLAB09 and try to understand as much as you can.
Wonderful. Mr. Fan, could you please upload the video recording of yesterday?
I did.
You did already?
Yeah. I already uploaded yesterday. That means on 24. Okay? And today will be 25. I will be uploaded for the right.
Thank you.
Mr. Fan, I think the video is not there. The video of yesterday.
Okay, now I show you. Okay.
There are only 2 videos of memory.
Okay, I show you. Okay, go here. Go to video. That
Yes.
video for video.
Can you see?
Huh. I already did it. Okay. Okay. I will do it on 19.
Thank you. Thank you. Cool.
Okay, thank you. Let me know. It's supposed to be. Okay. So that will be I upload. Yesterday we already. Okay. I will do it now. Okay.
Wonderful. Thank you.
Yeah, we'll see your guy next week. No class on Monday, right?
Except for Kumi.
Okay, no class on Monday.
Thank
Okay.
you.
Thank you.
Thank you.
Okay.
Mr. Pham,